tendency to outcompete the desired plantings. Now, if you're getting away from the pond itself or the wetland and you're talking perennial turf establishment, when we go out to inspect, as long as there is comprehensive coverage, we're not getting into the weeds, if you will, and looking at, all right, is this truly Bermuda grass, or is this fescue? Is this sedges in here? We're not getting that into the details about it. As long as there's comprehensive coverage, and that may include varieties of different weeds, as long as it's on the side slopes, we're fine with that. When you get into a turf grass bioretention, no, you don't want to have a lot of terrestrial type weeds in those basins. But as far as dams and side slopes, as long as it's covered and comprehensively covered, any variety of grasses, whether it be installed grasses or volunteer grasses and weeds, for the most part are acceptable. I hope that answers the intent of that question.
Okay, I'll go to the next question, and this is for either one of you guys. It says, would you advocate that simpler is better in terms of potential for failures and needs for maintenance? It seems some of these SCMs are seedling vegetation plans are more complicated than they need to be.
Mark, you want to stab at that, or let me hit it?
Go ahead, Thomas.
So from my perspective, yes, simpler is better. We do want diversity, but the reality is not all species compete equally. And so I'll use the example of soft rush versus cardinal flower. Soft rush is bulletproof. You can plant it almost any time of year. It's naturally occurring. It's going to volunteer in a lot of areas. And you can get a really nice buffer of soft rush established around a wet pond. If you wanted to have an equal buffer of cardinal flower, it would take a tremendous amount of effort to get cardinal flower established and prolific enough to even come close to competing with the rushes. Both fantastic plants, both approved for these types of planting plans, but the two just simply don't compete equally when you actually get them into the real world. So not all plants are equal. Some of the most, in my opinion, bulletproof planting plans keep it simple to your pickerelweed, your iris, your soft rush, and your carrot sedges, right? So you have diversity is there, but you're not getting what I consider kind of cute with it, where you're putting a little flower here, a little flower there, because those oftentimes, before they actually flower, present as a weed like anything else. And if the maintenance contractor is uninformed, they're going to mow those flowers down before they even have a chance to head out. And just that's simply because they don't present very well, and they get kind of lost in among all the other grasses when people are just uninformed. Whereas if you have a cluster of mature rushes, irises, it's pretty obvious that they're intended to be there, and they are very different than those around them. So I would say, as far as the planting plans go, simpler is certainly better.
Thomas, I'd add, I think it's a good idea if you're going to include some of the species such as cardinal flower that don't seem as hardy as, say, a pickerel weed, maybe to group those together, and rather than intermingling your plants like it's typically done in our industry, maybe have groups of cardinal flower versus groups of pickerel weed. I think that could be helpful in getting some of these less dominant species established.
I think that's a fantastic point. He's exactly right. So if you've got a nice cluster of very similar plants clustered together, yeah, that's going to, the odds of that presenting and surviving is much higher than if you were just one here, one there, one here, one there. Odds are they're going to get outcompeted by anything around them that's going to grow taller in nature. So that's a fantastic point, Mark.
Okay, so Mark, it's up to you. Right now, we still have 209 people that's still tuned into the webinar. So if you want to go for another 5-7 minutes or whatever, then you're good with that. And let me just remind people that our next webinar is November the 17th, and Lauren Kulajig is going to be speaking about the statewide action plan for nature-based strategies in North Carolina. So I'll be sending everybody information about that. So Mark, like I said, if you want to continue for another 5 minutes or so, we still have quite a few people that's still tuned in. It's up to you.
Sure, I'll do that. I've got one project I think folks will probably find interesting. Hopefully,
Okay, all right. I'll mute my mic and continue.
and I will try to. It's got a lot of twists and turns, but I will do my best to get through it in about 5 minutes. Okay. Okay, can everybody see the slide now? I'm assuming you can. Okay, good. Got a thumbs up. Cool. All right, so this is a project. If you look here, this is a great looking fire retention. No problems at all. And then unfortunately, this is the outlet discharge from this particular device, and it looks like chocolate milk. So there was a turbidity issue here. And to make it even more obvious, this particular discharge actually goes into a culvert underneath the roadway and then discharges into a pond. And so this is the downstream pond. You can see what the discharge or effluent from this fire retention was doing to the pond. And so the first thing we did is we came in and we used the sewer camera and videoed the under drains. And we didn't find any problems as far as, no connections, no problems with the joints or seams, no obvious sediment intrusion. But if you look here, after we were able to determine the under drains, the integrity of the pipe itself was in good shape, but we did see a lot of clay and sediment inside of the pipes. And so doing some research with the owners of this facility, they produced this photograph, and this is the initial build of that site. And as you can see, the contractor that built this placed the under drains directly on top of clay. I believe most plans that we see call for at least 2 inches of gravel to be bedded, across your bottom with your pipe on top of that. We'll talk about that more, but rather than incurring the cost of a complete reconstruction, we tried to do some creative attempts here to see if we could possibly treat this turbidity with less expensive measures. And so the first thing we tried is the only thing really before we did finally bow down and bite the bullet and reconstruct the device. We tried to we retrofitted an IWS, internal water storage here. The thought was maybe we could settle out some of the sediment before it discharged, and especially over time, maybe we could see a cleaner outlet discharge for this device. But that presented a whole realm of problems because with trying to create the internal water storage, we started finding that new water pressure was creating drainage through the actual riser structure. This is just an example. This is one of many, by the way. So we get a rain event, we'd go out and take a look at the site, and then we'd find a leak. And so we did this process for several different rain events and added grout, and finally got the riser structure buttoned up. And then we found out that the outlet pipe or principal spillway pipe was actually experiencing soil piping. And so that's this is just a picture during rain, and actually you can see the discharge is a little bit cleaner, or it wasn't discharging at that point, but the under drain water itself was actually looked a little better than it did initially. But the problem is, the principal spillway, you can see here, our first joint had water draining through it. This is a second joint downstream. You can see water flowing in. And then this is actually a catch basin on the street that's just downstream from the riser and principal spillway pipe connects to this. So this is roughly 15 linear feet. And you can see water was traveling along the outer diameter of that pipe all the way to the catch basin itself and streaming in. So at that point, the owner of this facility decided to abandon the attempt here of lower cost turbidity reduction and just go and reconstruct the whole device. And so we excavated the riser here, and first thing we found was that it had been backfilled with gravel. So obviously that gravel was causing water to leach into the dam, and then this just shows the water. I'm gonna speed up here because I know I said I'd take 5 minutes, and I'm gonna get lost in the weeds here. This is kind of a really convoluted project, but you can see the water here. This is going under the riser, and then this is after we'd removed all the gravel, and this arrow just shows basically a pipe, a void underneath the bottom of the pipe. Also like to point out here, this is concrete. And this is something common we see in the industry. Someone attempted to pour an anti-seep collar, but they didn't get it underneath the pipe. And so, we see that all across the industry. So that's just something I had mentioned, and try to, it's very important to get these seep collars and concrete cradles a foot below this, the bottom of your pipe. And this just shows being prepped. The repair here was a concrete cradle, and this debris, this actually came out of the dam for whatever reason. The people that built this decided it'd be a great idea to backfill with bricks and riprap and all types of materials that you can't compact, which just exacerbated the situation of water piping through a dam. This just shows the concrete cradle install. I want to mention here, we added sodium bentonite because this riser was sitting on a pretty thick bed of gravel. We added sodium bentonite, about 1,000 pounds around the edge of this, and then compacted clay. You can see the jumping jack on top of that to seal that and eliminate any water from being able to get in underneath that structure. This is something else we found is if you remember the picture I showed of the underdrain on red clay, this is the old, what I would assume the in situ soil. For some reason, they brought in clay and compacted on top of organic material rather than excavating it and hauling it out. So, once we dug out the gravel and started to remediate this basin, we found all this organic material that needed to come out. You don't want to build a foundation on top of decomposing material. We also found random, gigantic, abandoned pieces of concrete inside the structure, and this just shows a pile of debris that came. This is the organic material mixed with rocks and then some of the gravel. This is all waste material that never should have been inside of the bioretention. So it's pretty amazing that was there. Also, we found a storm sewer pipe that was supposed to have been demolished and removed, but it was actually about 10 feet into the basin itself and had a very poor cap that was not watertight. As you can see here, this is all wet material. Soil was migrating into this abandoned storm sewer. So, we took out that joint, filled this hole. I don't have a great picture to show you guys, but I wanted to call it out on here. This is after the underdrain system was in place, and we were backfilled with gravel. We put a layer of non-woven geotextile separation fabric along the bottom. In addition to that 2-inch thick layer of gravel that I mentioned, the underdrain pipe would be laid on. We put fabric in too to prevent clay from wicking up into our underdrain system and resulting in turbid discharge. This just shows, I wanted to include that picture again just to remind you guys of what it looked like during initial construction that led to this problem. These are the actual underdrain pipes that came out. You can see the clay caked on them. This is a view. This is what it looked like inside these pipes. So no wonder the discharge was so turbid. Just a picture of basin under construction. We lab tested the bioretention soil, found out it was good material, about 600 tons of earth here engineered soil media we were able to save and reuse. So at least we're able to save some money there. Obviously, always erosion control is a good idea to make sure you have, especially when you're trying to rehab a bioretention. We experienced multiple rain events at this site, and it's a large parking lot that sheet flows into this device. So you can see here, we were lucky that we had these wattles in place, and it protected our almost put back together device, and prevented soil from migrating into our new mulch layer. And this is the final result. We were able to clean up the discharge. And so I'm going to go ahead and stop there, guys. I've got tons of projects I can show you guys, but I know it's pretty late. So I appreciate you having me and listening to my presentation.
Thanks so much, Mark and Tom, for your presentation today. We got a lot of good and positive feedback, but I do have one quick question if you want to address this really quick. Mark, it says, could you have applied some PAM to treat the turbidity?
Yeah, we explored that option. We actually found we found a soil specific polymer that did lock down that sediment. And we actually put in a flock log with that soil-specific polymer with our IWS system, which may have been why some of that water looks so much better. But ultimately, the owner of the facility decided not to go that route because of the need to continuously or periodically reintroduce the polymer. It's not going to be a one-time fix. It's going to be something you would need to do periodically, and it was unknown whether it would ultimately clog the perforations in the pipe, but it's definitely a good thought.
All right. Well, I think that concludes everything, all the questions. And you guys, I will definitely have this, the slides and things like that up on the website. It may take a little bit longer than normal because we're still doing some reconstructing and things of that nature to the site. But yes, so you guys should be able to have access to all of this information. Okay. And with that being said, we kept you guys a little bit longer. Thank you again for joining and hope you guys have a wonderful rest of the week. Again, Mark and Thomas, thank you so much. We greatly appreciate your participation in our webinars. You guys have a wonderful rest of the day.
Thanks for having us. You guys have a great one.
You too.
Bye.
All right. Bye-bye.
Bye.